Hey guys, welcome back. So in this session, we will see the demonstration of decision trees in R programming. So we have seen what's the importance of decision tree in data science and how the steps work in the previous sessions, right? So let's have a demonstration of that. So decision tree are useful supervised machine learning algorithms. They have the ability to perform both regression and classification tasks. It is characterized by nodes and branches, where the tests on each attribute are represented at the nodes. The outcome of this procedure is represented at the branches, and the class labels are represented at the leaf nodes. Hence, it uses a tree-like model based on various decisions that are used to compute their probable outcomes. These types of tree-based algorithms are one of the most widely used algorithms due to the fact that these algorithms are easy to interpret and use. Apart from this, the predictive models developed by this algorithm are found to have good stability and a decent accuracy, due to which they are very popular. So let's begin the code. So we will examine the concept with the help of an example, which is the most widely used reading skills dataset. And we will visualize a decision tree for it and examine its accuracy. So the first step is to run the libraries. So make sure to install these libraries before you load them. So the libraries required for this example are datasets library, CA tools library, party library, dplyr library, and magittr library. Okay, so we will load them. Since I've already installed them, you can go ahead and first install these libraries. So we have discussed about entropy and information gain in the previous sessions, right? So library, datasets, CA tools, party, dplyr, and magittr. All right. So once this is done, you can check if they are loaded properly. If something is not installed, you can install it. So then we will run this. We will load the dataset reading skills and execute the head of reading skills. Okay. So head will give us the initial rows of this dataset. Okay. So this is the output. As we can see, there are four columns, that is native speaker, age, shoe size, and score. Thus, basically, we are going to find out whether a person is a native speaker or not using the other criteria and see the accuracy of the decision tree developed in doing this. So we will split the data set into 4:1 ratio for train and test set. So sample data equals sample dot split. We are splitting reading skills and the ratio is 0.8. Okay, then train data equals subset of reading skills, sample data equals 2. Okay, so this is the training data. We are setting the sample data equals 2. sample data equals true. Then how we define the test data. Test data equals subset of reading skills, sample data equals false. So this is how we split the data in R for decision trees. Okay, so separating the data into training and testing set is an important part of evaluating data mining models. Hence, it is separated into training and testing sets. After the model has been processed by using the training set, we test the model by making predictions against the test set because the data in the testing set already contains known values for the attribute that we want to predict, and it is easy to determine whether the model's guesses are correct or not. So after this, the step 4 is to create the decision tree model using the C tree and plot the model. So model equals C tree, native speaker, and train data. Then we will plot the model. Okay, so let's run this. Yes. So we got this output. So we saw the basic syntax of creating a decision tree. So we pass the formula and the data into the C tree function, where formula describes the predictor and response variables, and data is the data set used. In this case, native speaker is the response variable, and the other predictor variables are represented by dot. Hence, when we plot the model, we get this graph as the output. Not graph, the decision tree as the output. So from the tree, it is clear that those who have a score less than or equal to 31.08, okay, and whose age is less than or equal to 6 are not native speakers. And for those whose score is greater than 31, under the same criteria, they are found to be native speakers. So just see the yes and no values there. Okay, if the score is greater than, so native speaker, here in the output you can see yes, then score is 32.29. Then for no, the score is 49. All right, so like this we will get the output. Okay, when you use this C3, maybe few things might have been updated, you may get different results. All right, so I'm showing you the C3 syntax, C3 formula comma data. Okay, so just remove that syntax and let's go ahead. Now let's make a prediction. So we will test the people who are native speakers and those who are not. So predict model equals predict C3 comma test data. So we will pass the test data to predict the model. So what does this do? This creates a table to count how many are classified as native speakers and how many are not. All right. So this creates a table to count how many are native speakers, how many are classified as native speakers, and how many have not been classified as native speakers. So M80 equals table test data dollar native speaker comma from the predict model. Now let's run this. So C tree cannot be found. So there is a underscore which is not needed. Okay, let's see if it's working now. So no applicable method for predict. Let's replace the C tree with model. Okay, let's replace this C tree with model and see if it's working. Okay, all right. So you can see the actual no and the predicted no is 6. The actual yes and predicted yes is 18. Okay, so you can see the prediction is very good here. So if it is an actual non-native speaker, then it has predicted him as non-native speaker. So it is 6 versus 6, which is very good. And if it's an actual native speaker, and how much he has predicted is 18. So the model has correctly predicted 18 people to be native speakers and 6 to be non-native speakers. But it has predicted 20 by mistake as native speakers, that is false positive, and false negative it has predicted as 6. So the next step would be determining the accuracy of the model. So you can run the accuracy test. So let's see that, and we will see what is the accuracy. So how can we run this accuracy test? So accuracy test equals sum of diagonal values of m underscore 80 divided by sum of m underscore 80. So just see if we do mistakes, how will the errors come and how we should rectify the mistakes. Okay, the predict applied to an object of class function, no applicable method. Okay, what's wrong here? So finally, we will determine the accuracy of the model. So this is the last step of this program. So we'll print the accuracy of the model. So match table not found. So it should be m underscore 80 divided by sum of m underscore 80. So let's run this now. So now we will get the accuracy of this model. Okay. So here the accuracy test from the confusion matrix is calculated to be around 0.96. Hence this model is found to be 96% accurate. So decision tree are very useful algorithms as they are not used to choose alternatives based on expected values, but are also used for classification of priorities and making predictions. So it is up to us to determine the accuracy of using such models in the appropriate applications. So the decision trees are easy to understand and interpret. They don't require data normalization. They don't facilitate the need for scaling of data. The pre-processing stage requires lesser effort compared to other major algorithms, hence in a way optimizes the given problem. So it requires higher time to train the model. So this is a drawback, and it also has a considerable high complexity and takes more time to process the data. So when decrease in user input parameter is very small, it leads to the termination of the tree itself. And sometimes the calculations can get very complex. So these are some disadvantages or drawbacks of the decision tree. So we will do one more example on decision tree in the next lecture. Any questions, you can mail us. All right. Thank you.